Let's now compute the price of a European call option. A European call option is a derivative product that gives you the right to buy the asset at time t0 plus t, maturity, for the price k. The asset at time t0 has the price S0. The payoff defined by the contract at t0 plus t depends only on the value of the asset at maturity and is simply the maximum between these two quantities. Since you've bought the right to buy the asset at time t0 plus t, if the asset is worth more than the strike price, then you'll buy it at price k and then sell it to the market at price S at t0 plus t. In the opposite situation, if the price of the asset at maturity is below the strike price, then you wouldn't exercise the right. You wouldn't buy the asset for a price k which is larger than the actual price in the market of the asset. So you would get 0. In the Black-Scholes model, the price will just be the discounted expected value of this payoff. European call options can be classified according to what is called the moneyness of the option. We say that the option is at the money when the strike price is equal to the initial price of the asset. We say that the option is in the money when the strike price is smaller than the initial price of the asset. Finally, we say that the option is out of the money when the strike price is larger than S0. Here are the payoffs of the European call option in different scenarios. In this first scenario, the underlying asset at expiry has a price of 101.85. Since the strike price is 95, the payoff will be the difference between 101.85 and 95, that is 6.85. This quantity highlighted in green. However, this is a simulation, so we could have a different scenario. And here, the underlying has ended up with a price at maturity of 90.64. That's below the strike price of 95. So here, since it's an option, we wouldn't exercise the right and the payoff is 0. We could continue doing simulations. And here, for instance, we have a positive payoff. Here we have 0 payoff. And again, there could be many scenarios that you could simulate, all of them with different payoffs. The price of the option is the expected value of these payoffs multiplied by the discount factor. Here is the code we have used to price the option. The initial price of the asset on which the option is defined is 100. The volatility is 0.4. The parameters that define the option are strike of 90, maturities in 2 years from the time at which the contract for the option is drawn, and the payoff is the maximum of the price of the asset at maturity minus k, the strike price, and 0. We're doing risk-neutral pricing, and we have a 5% interest rate. Finally, this is the evaluation of the function that computes the price. We get a price of 30.76.